Welcome back to where we explore the cutting edge of technology. Today, we're diving into something truly revolutionary, GameNGen, a game engine powered entirely by neural networks. If you thought traditional game engines were advanced, think again. GameNGen is set to redefine how games are created and played. Stick around to find out how this incredible technology works. So, what exactly is GameNGen? It's not just another game engine. It's a groundbreaking leap forward. GameNGen uses advanced neural networks to generate entire game environments in real time. Imagine playing a game where every frame you see is created on the fly by a neural network. GameNGen is capable of running Doom, the iconic 1993 game, at 20 frames per second using just one TPU. But the real magic is how close the simulation gets to the real thing. So close that most people can't even tell the difference. Now, let's get into the tech behind GameNGen. At its core, GameNGen uses a diffusion model, a type of neural network that excels at generating images and videos. But here's the twist, GameNGen doesn't just generate static images. It creates an entire, interactive game environment in real time. The process starts with training a reinforcement learning agent, or RL agent, to play the game. This agent learns by interacting with the environment, much like how a human would. The data collected during this training, frames, actions, and game states, forms the backbone of GameNGen's learning process. This data is then fed into a generative diffusion model. Unlike traditional models that might simply generate images, GameNGen's model predicts the next frame in a game based on the sequence of previous frames and actions taken by the player. It's like predicting the future, one frame at a time. One of the challenges in creating a neural game engine is ensuring the accuracy and stability of the generated frames. This is where GameNGen's auto-regressive sampling comes into play. Each new frame is generated based on the previous ones, but small errors can add up, leading to visual glitches. To counter this, GameNGen uses a technique called noise augmentation during training. By adding controlled amounts of noise to the training data, the model learns to correct errors and maintain high-quality visuals over time. This technique is crucial for preventing what's known as auto-regressive drift, ensuring that even long gameplay sessions remain visually consistent and accurate. Another key innovation in GameNGen is the fine-tuning of the latent decoder. This decoder is responsible for turning the compressed data back into high-resolution game frames. Without fine-tuning, important details like health bars or ammo counts could be lost or distorted. By fine-tuning the decoder, GameNGen ensures that every frame is not only accurate but also rich in detail. This is especially important in fast-paced games like Doom, where every piece of information on the screen matters. Now, let's talk about performance. GameNGen is designed for real-time gameplay. Typically, diffusion models require dozens of denoising steps to produce high-quality images. But GameNGen achieves smooth gameplay with as few as 4 steps per frame, running at 20 FPS on a TPU v5. This optimization is key to making GameNGen viable for real-time applications. And if that wasn't impressive enough, with further optimizations, GameNGen can push to 50 FPS. So, what do the results look like? In a series of tests, GameNGen was able to produce game visuals so accurate that human evaluators could barely tell them apart from the real thing. That's a huge achievement for a neural network-driven engine. However, like any cutting-edge technology, GameNGen isn't without its limitations. The model currently has a memory window of about 3 seconds, which can lead to inaccuracies over longer gameplay sessions. But these challenges are not insurmountable.